We have a couple more examples to look at for solving a quadratic equation by completing the square. So we'll start with number 11, v squared minus 6v minus 5 equals negative 10. So I need to get my variable terms to one side and my constant terms to the other, so I will add this 5 over. So now I have v squared minus 6v equals 5. Since I don't have a coefficient in front of my v squared, I'm on to my next step, which is to find b divided by 2 squared and add it to both sides. So I'll take negative 6 divided by 2 is negative 3 squared. Negative 3 squared is positive 9. So I'll be adding 9 to both sides. Then I will factor using that negative 3. So the left side factors into v minus 3 squared. And that's going to equal 5 plus 9, which is 14. And now I can just take the square root of both sides. Square root, square root. On the left side, that leaves me v minus 3. And on the right side, I will have plus or minus the square root of 14. Now I want to see if square root of 14 breaks down. 14 would be 2 times 7. And those are both prime, so it's not going to simplify anymore. So I'll just go ahead and add my 3 over, and remember that 3 is going to go in front of the plus or minus. So I get v equals 3 plus or minus the square root of 14. Well, since those are not like terms, they cannot be combined, so that would be the final answer. We have one more to look at for completing the square. Number 12 is x squared minus 12x minus 22 equals negative 9. Okay. So you know the drill. First we're going to add the 22 over to the other side. So now we have x squared minus 12x equals 13. Then we will find half of b. b is negative 12. Half of negative 12 is negative 6, which we square. So negative 6 squared is 36. And that's what we will be adding to both sides. So plus 36 plus 36. Then we will factor the left side using that negative 6. So that will factor into x minus 6 squared. And that is going to equal 13 plus 36 is 49. Then we're going to take the square root of both sides. The left side will give me x minus 6, and the right side will be plus or minus 7. We'll then add 6 to both sides. So we get x equals 6 plus or minus 7. Now these are like terms. 6 and 7 can be combined, so we'll need to work the two problems. X equals 6 plus 7, which gives us 13, and x equals 6 minus 7, which gives us x equals negative 1. And finally, the last method that we're going to talk about for solving quadratic equations is the quadratic formula. In order to use the quadratic formula, your equation has to be in the format ax squared plus bx plus c equals 0. And then the quadratic formula is x equals opposite b plus or minus the square root of b squared minus 4ac divided by 2a. Now, there are a couple of things worth note here. One is that b squared is always going to be positive. The next thing that gives people problems is within this discriminant, when you have minus 4ac, if you'll just count the number of negative signs, that will tell you if you're going to be adding b squared and 4ac or subtracting b squared and 4ac. So if you have an even number of negative signs inside the radical, you're going to be adding the numbers. If you have an odd number of negative signs inside the radical, you're going to be subtracting the numbers. So let's look at some examples. We have number 13, which is 6n squared minus 12 equals 0. And right out of the gate we have kind of a special case. In this problem, A is 6 because it's in front of the squared term, and B is 0 because there's no just plain n term, and C is negative 12. So in our quadratic formula we'll have, in this case it's n equals instead of x, so n equals the opposite of b, which will be 0, plus or minus the square root of 0 squared minus 4 times a times c divided by 2 times a. Now here's where I was talking about how many negative signs do you have. Here I have 1, 2 negative signs. So what I'm going to be doing is adding the 0 squared and whatever 4 times 6 times 12 is, which I think is 288. So then n will be 0 plus or minus the square root of 288 all divided by 12. I don't want to do any simplifying with the 12 until I've simplified my radical. 288 actually breaks down to be 2 times 144, and 144 is 12 times 12. So right now I can see that a pair of 12s comes out, the 2 stays in. So I have 0 plus or minus 12 square roots of 2 all divided by 12. Now the 0 plus or minus is not necessary, so we really just have plus or minus 12 square roots of 2 divided by 12, and the coefficient in the numerator can simplify with the denominator, so my answer is plus or minus square root of 2, and that will be the value for n. I have 3 more of these to work, so you can get the gist of the quadratic formula. So 14, we have x squared minus 10x minus 75 equals 0. This is already in the correct format. It has to equal 0 before I can get started. And then in this problem, a is 1, b is negative 10, and c is negative 75. So when we start off our quadratic formula, x is going to equal the opposite of b, so positive 10, plus or minus the square root of, remember b squared is always positive, so that's going to be 10 times 10, which is 100, minus 4 times a, which is 1, times c, which is negative 75, all divided by 2 times a, which is 1. Now again, count your negative signs in here. There's 1, 2. That means I'm going to be adding. So I'm going to take 100 plus whatever 4 times 75 is. 4 times 75 is 300. So x is going to equal 10 plus or minus the square root of 400 all divided by 2. Let's see, the square root of 400. 400 would be 4 times 100. 4 is 2 times 2. 100 is 10 times 10. So I can bring out a 2 and bring out a 10, and there's nothing left inside. So x will equal 10 plus or minus 2 times 10, so 20, all divided by 2. Now I can simplify, because each of the 3 spots here can be divided by 2. So I get x equals 5 plus or minus 10 all over 1, which is the same as just 5 plus or minus 10. And since these are like terms, that's going to give me 2 answers. 5 plus 10, which is 15, or 5 minus 10, which is negative 5. Let's see if we can get 2 more problems on here. Number 15, 5a squared plus 7a plus 2 equals 0. Okay. A is 5, B is 7, and C is 2. So this time we're solving for A. So A equals the opposite of B, negative 7, plus or minus the square root of B squared, 49, minus 4 times A, which is 5, times C, which is 2, divided by 2 times A, which is 5. Okay, now this time we have only one negative sign in here, so we are going to be subtracting. So I'm going to take 49 minus 4 times 5 times 2. 4 times 5 is 20, times 2 is 40. So 49 minus 40. So A equals negative 7 plus or minus the square root of 9 all over 10. Well, the square root of 9 is actually 3, so A equals negative 7 plus or minus 3 all over 10. And right now nothing simplifies, but I do have like terms, so I'm going to go ahead and break this down into negative 7 plus 3, which is negative 4 over 10, and negative 7 minus 3, which is negative 10 over 10. And now I can simplify. So A is going to equal negative 2/5, or A is going to equal negative 1. And we are on our final problem for solving quadratic equations, number 16. 12k squared minus 5k plus 1 equals 0. That's already in the correct format where it equals 0 and it's in standard form. So we'll go ahead with A is 12, B is negative 5, and C is 1. So we'll have K equals the opposite of B, which will be positive 5, plus or minus the square root of B squared, which will be 25, minus 4 times A, which is 12, times C, which is 1, divided by 2 times A, which is 12. I have one negative sign, so I'll be subtracting. So inside the discriminant, that will give me 25 minus 4 times 12 is 48. So K equals 5 plus or minus the square root of 25 minus 48 is negative 23, all divided by 24. Now that square root of negative 23, nothing will come out of 23 because it's a prime number, but this negative sign makes it complex. So the negative inside the radical is going to become an I. So this will be 5 plus or minus I times the square root of 23, all divided by 24. And that is as simple as this one gets.